Hello, in today's lesson we're going to look at piecewise functions. A piecewise function is essentially pieces of different functions graphed over different intervals, and they often don't overlap. I guess a real-life example of a piecewise function we can relate to the pandemic with the coronavirus. We know that when this all started, the number of cases was increasing exponentially. So my graph over the interval x is from 0 to 2 would be represented by an exponential function. Then the number of cases plateaued. So maybe I'd represent the interval from 2 to 4 as a constant function. And then hopefully from here on out, the number of cases continues to decrease. So maybe on the interval from 4 to 7, that function would be represented by a linear function with a negative slope. So just kind of to give you a real life example or maybe explain how these might be represented. All right, so let's take a look here. What we're going to do here is I'm going to do 2 or 3 examples, and then I'm going to have you guys finish the rest as the assignment. So our directions: carefully graph each of the following. Then evaluate each graph at the specified domain value. Then identify the domain and the range. So let's take a look here. Our piecewise function has 2 pieces in it in number 1. It's represented by the function 2x plus 1 only over the interval x is less than or equal to 2. And our second portion is represented by the linear function 1/2 x minus 4, but only over the interval x is greater than 2. And then these are the 3 values we want you to evaluate the function for, and then identify the domain and range. So let's get started on the first part, graphing. Let's see, so my first part is a linear function, negative 2x plus 1. So my y-intercept is 1, and my slope is negative 2, so I'm going to go down 2 and to the right 1. And I like to put some points to the left of the y-axis as well, and I'm going to draw my straight line. However, I'm only going to include the part of the line where x is less than or equal to 2. So I'm going to go to x is 2, which is right here, and I'm going to draw a straight line only in the negative x direction. So my function does not include these points or this part of the line. If you guys didn't notice, if you are in Notability and you draw a line that's not perfectly straight, but hold your finger or pen at the end, it'll draw you a perfectly straight line. Okay, moving on. My second part, or my second piece, is 1/2 x minus 4. So I'm going to start down at negative 4, and my slope is 1/2, so up 1 to the right 2. However, I'm only going to include the part of the graph where x is greater than 2. Now, I technically should have an open dot at x equals 2, but there's a solid blue dot right underneath it, so it doesn't really matter. So that's it. I'm going to erase that other point. That is the graph of my piecewise function of f of x. Now let's evaluate a couple of these values. My first one is f of negative 2. So if I go to negative 2 on my x-axis and go up, it looks like that has a value of 5. It's a poor looking 5. F of 0, it looks like has a value of 1. And f of 4, so x coordinate of 4, go down, it looks like I have negative 2. So those are my 3 values. My domain, the domain is the set of x coordinates covered by the graph. These linear functions go all the way to the left and all the way to the right in the negative and positive x direction. So my domain would be from negative infinity to infinity. And don't forget, infinities always have the open parentheses because it's not included. My range, the range is the y coordinates covered by the graph. My lowest y coordinate is negative 3. And it is included, so there's a square bracket there. And then it does go all the way up. So my range is going to be from negative 3 to infinity. Again, infinity always has a parenthesis, and my negative 3 has a square bracket because it's included. Okay, let's take a look at the next example because it does have a quadratic equation, and I'll show you how specific we have to be on graphing these. Again, my first portion is a linear function, 2x plus 1 over the interval x is greater than or equal to 1. So y-intercept, slope of 2, and x is greater than 1, greater than or equal to. So I do have a solid dot at 1, and I'm going to include the portion of x is greater than 1. So I'll erase my other point there because I don't need it because it's not my interval. My second portion is a quadratic equation. It's the quadratic equation x squared plus 3. So I know my parent graph of x squared is a parabola with the vertex at the origin. However, the plus 3 is a vertical shift up 3. So I am going to put my vertex over here at 3. And since this is just x squared, not 1/2 x squared, there's no vertical stretch or shrink. I can go left 1 up 1, right 1 up 1, left 2 up 4 because it is x squared, right 2 up 4. Now this is x is less than 1, so a couple things here. I am going to have not a solid point, but an open point at x equals 1. And I'm going to draw my parabola just for this portion of the graph. So that's a pretty good looking representation of this piecewise function. All right, let's evaluate the function for some x values. X is -2, or I'm sorry, f of -2. It looks like I'm up there at 7. F of 1. Aha, now here at x equals 1. I have both parts of my graph. However, the blue graph has the filled in or solid point, and the red graph has the open or hollow point. So I'm going to choose the solid point, which has a y coordinate of 3. Okay, f of 5. Let's see, go over to x equals 5. Uh-oh. So my graph is off of the coordinate plane here. I can't actually see what the y coordinate is. So what I'm going to do is I'm going to take 5 and plug it into one of the two pieces. Now you can do this a couple different ways. If you're looking at the graph, you can easily see that the y coordinate would be on the blue portion of the graph. Or if you look at the intervals, 5 is greater than or equal to 1. 5 is not less than 1. So I'm going to plug 5 into the top portion of my piecewise function. So I'm going to say 2 times 5 plus 1, and that would give me 11. Okay, next we're going to look at writing a piecewise function given a graph. So you're going to finish 3, 4, 5, 6 as your assignment. And I don't know, maybe I'll try number 8. Number 8 looks good because we have a constant function in there. So I have two pieces again. My blue piece and my red piece. My blue piece is a linear function with a positive slope. Now how I like to do this is I kind of imagine or I draw the remainder of the graph of the line that would be there, even though it's not over that interval. So what I can see is I have a slope of 1. So 1x or x, and I have a y-intercept of 5. So my function, represented by the blue part, is x plus 5. However, it is only over the interval when x is less than 2. It's not equal to 2 because the point at x equals 2 is open. For my red portion of the graph, it's a constant function, and that constant is -2. So that's it for the function portion, and it is over the interval, so I'm going to write a semicolon. X is greater than or equal to, -2. I put positive 2 on that first part, that first interval. So that first interval should be x is less than negative 2. Okay, and that's it. You're going to finish up the rest of these as practice, and we'll discuss them tomorrow. Have a good day.